Morning, everybody. It is October 19th. It's Monday, and it's the day of a new unit. We're talking about proportional relationships this unit. So we're moving from equation solving to proportional relationships. Our do now for today says change each fraction into an integer or decimal. So go ahead and get these four fractions written down. So we've got -8/2, 9/18, 7/4, and -2/5. So I'll give you a few minutes to write those down and change those into integers or decimals, and then we'll go over them together. Morning, Nicolasa. We are working on our do now, so go ahead and write down these fractions. You're working on changing each fraction into an integer or decimal. And all you have to do is take your calculator and divide the top number by the bottom number. And we're going to get an integer or a decimal. So go ahead and start working on those. We'll go over them in about 1 more minute. If you guys are wondering what's on my shirt, I'm Starbucks Coffee because today's Spirit Day is dress up like your favorite thing, and I'm a coffee drinker, so. All right, we're gonna go over these. So this says change each fraction into an integer or decimal. So in our calculators, we just have to enter -8 divided by 2, which gives us -4. Then we've got 9/18, or 9 divided by 18. If we put that in our calculator, we get 0.5. 7 divided by 4, or 7/4. If we put that into our calculator as 7 divided by 4, we get 1.75. And finally, -2 divided by 5. If we put that in our calculator, -2 divided by 5, that's going to get us -0.4. So the reason I wanted to go over with how to do this, it seems like a very basic skill. But the reason I wanted to go over this is because we're going to be using this a lot in proportional relationships. So we're going to be setting up ratios and relationships with two numbers, and you're going to have to take the top number and divide it by the bottom number to get an integer or a decimal. So we'll talk more about that in a little bit. All right, so we're going to start proportional relationships today. So this says in 1870, the French writer Jules Verne published 20,000 Leagues Under the Sea. Good book, by the way. It's also a movie, I think. One of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. So this is asking us to complete the table. So this is saying one definition of a league is a unit of measure equaling 3 miles. So 1 league, and we'll see here, it says distance in leagues, 1 league equals 3 miles. So we need to finish the rest of the table. So if 1 league equals 3 miles, 2 leagues, so we get 3 by doing 1 times 3 equals 3. So 2 times 3 is going to give us 6. 6 times 3 is going to give us 18. And then we've got 36. Well, if to get from leagues to miles, I'm multiplying leagues by miles. To get to the opposite, to get from miles to leagues, I just need to divide distance in miles by 3 to get how many leagues. So 36 divided by 3, go ahead and put that in your calculator. 36 divided by 3 is going to give us 12. And that makes sense because if we do 12 times 3, we get 36. All right, and finally, we've got 20,000 because we're talking about 20,000 leagues under the sea. So 20,000 in your calculator times 3 is going to give us 60,000. It's hard for me to write small on this, so I just won't. All right, so we completed the table. What relationships do you see among the numbers in the table? So we already kind of talked about this, but one relationship we see is for every, so I'm just going to write for every 1 league, there are 3 miles. So this is meaning for 2 leagues, there's 6 miles. For 6 leagues, there's 18 miles. So we're kind of starting to see that relationship. So this next part says, for each column of the table, find the ratio of the distance in miles to find the distance in leagues. Write the ratio in its simplest form. So this is saying 3 divided by 1, so 3 miles divided by 1 league. 3 divided by 1 gives us 3. This next part, what divided by 2? If we're following the same thing, we already filled out our table. So blank divided by 2, so 6 divided by 2 gives us 3. Blank divided by 6, so 18 divided by 6 also gives us 3. 36 divided by 12, because we talked about 12. So 36 divided by 12 equals 3. And then 20,000, so 60,000 divided by 20,000 gives us 3. So what do we notice about these ratios? Well, I'm noticing that if we take distance in miles, so whatever's on the bottom, so we took 3, divided it by 1, we got 3. If we took 6, so whatever's on the bottom, and divided it by 2, we got 3. 18 was on the bottom, we divided it by 6, we got 3, and so on and so forth. So what do we notice about these ratios? They're all equal to 3. So no matter what we do, all of these relationships equal to 3. So all equal 3. Sorry, that looks like an X, but it's supposed to be equal. So they all equal 3. So we're going to reflect. If you know the distance between 2 points in leagues, how can you find the distance in miles? So if we know that for 1 mile, or for 1 league, it's 3 miles, we can go ahead and multiply however many leagues by 3, because we know for every 1 mile, there's 3 leagues. So for every 2 miles, there's 6 leagues. So how can you find the distance in miles? Multiply leagues by 3. All right, if you know the distance between 2 points in miles, how can you find the distance in leagues? So if we know that distance in miles is 3 and 6, we can go ahead and divide both of those by 3 to get to our leagues, because we know for every 1 league, there's 3 miles. So for if we know that relationship, we can go ahead and if we know the distance between 2 points in miles, how can you find the distance in leagues? Divide by 3. So we've made it clear, we know that the relationship is 3. So whenever we take miles and divide it by leagues, we're going to get a relationship of 3. So we're actually going to talk about what this relationship means. So this is the most important part of today. If you don't get anything else out of today, this is important. When a relationship has a constant ratio of y divided by x, it is called a proportional relationship. So that term proportional relationship is key. This is what our whole unit is about. So the value of that ratio is called k, which is the constant of proportionality. So this equation right here, k equals y divided by x, is super important, and that's called the constant of proportionality. If you guys remember from what we just did, we found out, so for every 3 miles divided by 1 league, we got 3. So our constant of proportionality in that last problem was 3. And we're going to talk about what that means in some more examples in a minute. All right, so we're gonna do an example. This says Megan earns $12 an hour at her part-time job. You guys are 8th graders, you guys are gonna be, so you guys are like 13, you guys are gonna be working in a few years. So I remember I had my first job sophomore year of high school, so you guys aren't that far away. So this says Megan earns $12 an hour at her part-time job. Show that relationship between the amount she earned and the number of hours she worked is a proportional relationship. Then write an equation for the relationship. So what do we know? We know that X is hours. So for every 1 hour she works, she makes $12. So with that being said, for every one hour she works, she makes $12. So then for 2 hours of work, she's gonna make, so we're gonna do 2 times 12. So 2 times 12 gives us 24. For every 3 hours she works, we're gonna do 3 times 12, which gives us 36. For every 4 hours she works, she's gonna make 48 because we're gonna multiply each by 12. Because for 1 hour of work, she makes $12, 2, 24, 3 hours, 36, 4, $48. So we filled out this table. It's kind of like a table. So we need to write an equation to show the relationship. So if we look back to the constant of proportionality equation, this should be in your notebook somewhere written, constant of proportionality, and you should have this equation, K equals Y divided by X. So it's always Y divided by X is going to give us the relationship. So to do this, we're going to have So Y divided by X equals K. So if we have Y is 12 and X is 1, 12 divided by 1 equals 12. So our constant of proportionality is going to be 12. So, and we can do that. We could take this part right here and we could write 24 divided by 2, and that would also give us 12. So the constant, it's a proportional relationship because each time it changes by the same amount. So it's changing by 12. So that constant of proportionality is 12. All right, this is going to be, I forgot I put this one in here. So this says 15 bicycles are produced each hour at the Speedy Bike Works. Show the relationship between the numbers of bikes produced and the number of hours is a proportional relationship. Then write the equation for the relationship. So 15 bicycles are produced. So I've got, so let's see, hours is going to be our X, and then bikes produced, I'll just put bikes, it's going to be our Y. So for 1 hour, 15 bicycles are produced. So in 2 hours, so 2 times 15 gives us 30. In 3 hours, so 3 times 15 gives us 45, so on and so forth. So show that the relationship between the numbers produced is proportional. So that's a proportional relationship because each time we're jumping by 15. So 4 would be 4 times 15, which would give us 60. So each time we're jumping by 15. So we want to write a proportional equation. So write an equation for the relationship. Well, if we take, remember, our equation is Y divided by X equals K. So K is that constant of proportionality. So we need to take 15 divided by 1, and that gives us 15. So our constant of proportionality is 15, which makes sense because we are jumping by 15 for every 1 hour. So for every 1 hour at work or at the Speedy Bikes workplace, for every 1 hour, they produce 15 more bikes. So our constant of proportionality is 15. All right, proportional graphs. So we're going to talk about this a little bit. So proportional graphs have 2 properties. The first property is that they're straight lines. So nothing like that, nothing like a curve or anything, always going to be straight lines. The second thing is that proportional relationships, proportional graphs, they go through the origin. So the origin is right here. That means 0, 0 on a graph. So if our graph started here for some reason, and we had a line that was straight, but it went through 0, 5, that would not be a proportional relationship, because a proportional relationship starts at the origin, so at 0, 0. And we'll kind of see more examples of this in a minute. All right. The graph shows the relationship between the amount of time that a backpacker hikes and the distance traveled. What does the point 5, 6 represent? So I'm noticing that this is a proportional relationship. It's a straight line and it goes through the origin. I can see that right here. It goes through 0, 0. So what does the point 5, 6 represent? Well, we're comparing time in hours to distance in miles. So at the point 5, 6, so this point right here, that means at 5 hours, the backpacker hiked 6 miles. So at 5 hours, 6 miles hiked. All right. So what is the equation of the relationship? So we're going to try and come up with the equation. So again, proportional relationships, our equation is y over x equals k. So remember, k is a proportional, or the constant of proportionality. We're trying to figure out the relationship between those two numbers. So if we know, so we're going to do, hours is going to be x, and then we'll do miles is y. And I'll make like a little table. All right, so we know that at 5 hours, we biked 6 miles. So to figure out what the constant of proportionality is, remember, we have to take y divided by x to figure out k. So this one's a little less obvious. So we're going to go ahead and we're going to take, let's see. So for my y divided by x, I'm going to do 6 divided by 5 equals, and then my calculator, 6 divided by 5 equals 1.2. So 1.2. So this means that if I wanted to fill out the rest of the table, and I can look at the table also. So this says for every 10 hours, 15 hours, they're going to be changing. So 5 times 1.2 equals 6. So 10 times 1.2 equals 12. 15 times 1.2 equals 18. So I can already see here that we are jumping in increments of 5, and here we're jumping at increments of 12, or of 6, excuse me. So these relationships are proportional. So what is the equation for the relationship? So 6 over 5 equals k. So our constant of proportionality is 6 divided by 5, but we also found out that k equals 1.2 when we put 6 divided by 5 in our calculator. So that is going to be our equation, and we found the constant of proportionality. So that's what it would be like to solve a problem like that. And again, stop me if you have any questions at any time. I don't want you guys to feel like just because you're at home, you can't ask questions. So if you don't feel comfortable unmuting yourself, you can always leave them in the chat. All right, so vocabulary. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is or is not constant. is constant. So remember, a proportional relationship is a relationship where the ratio of the quantities are equal to each other. So it is constant. So that means like in that last problem, we were jumping at increments of 5 here and 6 here. So it's constant. The relationship is not changing. It's the same every time. When writing an equation of proportional relationship in the form y equals kx, k represents the constant of proportionality. So this is interesting. We see here we've got y equals kx. I want to show you guys something really quick. So our constant of proportionality equation was k equals y divided by x. Oh, that's kind of sloppy. Hold on. K equals y divided by x. So if we wanted to undo that division between, so this bar right here represents division. If we wanted to move that x, we could go ahead and multiply both sides by x to move the order of things. And so what I mean by this is over here we've got x times k. So we've got kx or xk, whichever way you want to write it, and divided by x times x cancels. So we're left with y equals kx. So kx equals y and k divided by, or k equals y divided by x. These are the same equation. You'll see them kind of both ways. This is the way that you'll find the constant of proportionality most times. But if you're ever given, like if you're not given y and you want to get that for some reason, you can go ahead and find it that way. Write an equation that describes the proportional relationship between the number of days and the number of weeks in a given length of time. So we're going to complete the table. So this is saying for every 1 week, there are 7 days, which is a known fact. We know that in 1 week, there's 7 days. So in 2 weeks, how many days have gone by? So if for 1 week, there's 7 days, in 2 weeks, there's going to be 14 days. How did I know that? 1 times 7 is 7, 2 times 7 is 14. I can also, if I don't know that right away, I can go ahead and use my relationship or the constant of proportionality formula, which is k equals y divided by x. And I can take 7 divided by 1. So I took my y divided by my k, divided by my x. So 7 divided by 1 equals my constant of proportionality, which is k. So that means that 7 divided by 1, which is just 7. So our constant of proportionality is going to be 7. So that means each time we're moving by 7 in each of these, if we're moving in increments of 1. So let me undo that. So 4 times 7. So I'm noticing here we skipped 3. So we're going to do 4 times 7, which gives us 28. And then over here we've got 56. So we've got our y, but we don't have our x. So all we do is we do 56, and we're going to divide by 7. So to find that constant of proportion, we're using our constant of proportionality. So 56 divided by 7 gives us 8. And this makes sense because 8 times 7 gives us 56, just like the rest of the ones we've done so far. And finally, we've got 10. We need to figure out what goes in days. So for every 10 weeks, there are how many days? We know that our constant of proportionality is 7, so I'm going to do 10 times 7, which is 70. So x represents weeks. Y represents days. The equation that describes a relationship is for every 7 days, there is 1 week, which gives us our proportional or our constant of proportionality, which is 7 or 7 over 1. All right, finally, last one we're going to do today. Each table or graph represents a proportional relationship. Write an equation that describes the relationship. All right, so the relationship between the numbers of oxygen atoms and hydrogen atoms in water. So for every 2 oxygen atoms, there are 4 hydrogen atoms. So we've got, for every 2, there's 4. So this just wants me to write an equation that describes the relationship. So remember, we've got k equals y over x. So we've got 4 divided by 2. So I took my y and divided it by my x. So 4 divided by 2 equals 2. So our constant of proportionality is going to be 2. So 2 times 2 is 4. So 5 times 2 is going to give me 10. All right, but we've got our y here. So to get from x to y, we've been multiplying by 2. So to get from y to x, we're going to divide by 2. So 34 divided by 2 is going to give us 17. And then finally, 120 oxygen atoms. We're multiplying by 2 to get to our y value. So 120 times 2, that gives us 240. That's a bad 240. All right, so our equation was k equals 2. All right. Oh, I didn't realize this was 2 different ones. All right, this last one, sorry, this is actually our last problem of the day. Sorry, guys. So we've got the map of Iowa. So distance in inches and actual distance in miles. So in a map, they write things to scale. So for every 1 inch on the map, it represents a certain amount of miles in real life. So this is a map of Iowa. So this is saying for every 1 inch, there are 30 miles. So every time you see an inch on that map, it's going to be 30 miles. So our y is going to be distance in miles. So 30 miles is this point. So we've got 30. And then our distance in inches is our x. So we're going to divide by 1. So our constant of proportionality, our k, is going to be k equals 30. And that means for every 1 inch, it's 30 miles. And we can see that when we see 2 inches at 60, 3 inches at 90, and so on and so forth. So that's a straight line, a proportional relationship. So our equation is going to be k equals 30, or k equals 30 over 1. All right, and that's actually all we're going to do for today. So let me see something really quick. Let me move you guys around. In Google Classroom, last week you guys had a unit test you should have taken. So classwork. So this is last week. We had 3 days of review, a study guide, and a unit test. These were both due last week. Make sure you get them done if you have not. That unit test is worth a lot of points, so make sure you do that. And then this is this week, so intro to proportional relationships and exit ticket. I would say wait on intro to proportional relationships. However, this exit ticket number 5, if you watch this lesson today, you should be good to complete it. It's just 2 questions. Do you know what a proportional relationship is? So you should be good after that. I'll leave now. Let me stop sharing my screen and I'll stop recording.